Here's an example of simplifying a complex fraction in which there are some negative exponents. I have here y to the negative 1 power minus x to the negative 1 power, and that's all being divided by x to the negative 2 power minus y to the negative 2 power. So regardless of which method we use, the very first thing that we want to do here is rewrite this without negative exponents. So I'm going to get rid of the negative exponents, write everything with positive exponents only. So the basic negative exponent rule, to remind you how that goes, this is the negative exponent rule. In general, if you have a to the negative n power, that can be rewritten as 1 over a to the positive n power. And that's the rule that I want to use here. So y to the negative first power is equivalent to 1 over y to the positive first power. And we don't have to write the positive 1 power on the y. And then minus x to the negative 1 power is equivalent to 1 over x to the positive first power. And again, we don't have to write the positive 1 exponent. X to the negative 2 by the negative exponent rule is equivalent to 1 over x to the positive 2 power, or 1 over x squared. And then minus y to the negative 2 is equivalent to 1 over y to the positive 2, so 1 over y squared. That's utilizing the negative exponent rule. From here, then, we have to decide whether we're going to use method 1 or method 2 for simplifying the complex fraction. I generally prefer method 2 when there are multiple terms in the numerator and denominator, but you can also use method 1. I'm going to demonstrate method 2. So using method 2 here, we would look at the 4 denominators and just think, what is the common denominator among all 4 of these denominators? We always use the higher exponent, remember, when choosing the common denominator factors. So we would go with x squared, y squared. So we're going to multiply here the numerator and denominator by x squared, y squared. That's the least common denominator among all 4 of these fractions that are present within the complex fraction. X squared, y squared. Okay, so I'm using method 2. So to go from there, we need to distribute the x squared, y squared to both terms in the numerator and to both terms in the denominator. You can multiply it in your mind. That's fantastic. I'm going to show the step here. So we've got 1 over y. We need to multiply that by x squared, y squared. And then minus 1 over x. We need to multiply that also by x squared, y squared. Every term in the complex fraction gets multiplied by x squared, y squared. And in the denominator, we've got 1 over x squared times x squared, y squared. And then minus 1 over y squared times x squared, y squared. Okay, so from there, I'm going to go up here to continue. Let's do some reducing. So this y in the denominator underneath the 1 can reduce with one of these y's. I'm just going to cross off the squared to show that there's one y left. So we have x squared y as the first term in the numerator, x squared y. As for the second term, we can cancel this x with one of these x's, but I'm going to show it by crossing off the squared from the x. So we have a single x left and a y squared. So minus xy squared. There's the numerator simplified. The denominator can be done similarly. So in the denominator here, we can cancel out the x squared with the x squared, and it's just y squared times 1, which is y squared. And then for the second term in the denominator, same principle applies here. We can cancel out the y squareds, and it becomes x squared times 1, which is just x squared. Okay. To finish it from there, we need to try to factor the numerator and try to factor the denominator, see if they factor, and then cancel or reduce common factors if there are any. So I'm going to attempt to factor the numerator and attempt to factor the denominator. Looking at the two terms in the numerator, I believe they have something in common. They have an x in common, and they also have a y in common. So factor out the common factor of xy from both terms in the numerator. That would leave us from the first term with an x left over, and from the second term it would leave a y left over. So the numerator of the complex fraction now simplifies or factors to xy times x minus y. The denominator, y squared minus x squared, is a difference of squares. And differences of squares can always factor. So I'm creating two sets of parentheses here. Y times y would make y squared, and x times x would make x squared. With differences of squares, one of the signs is a plus and the other sign is a minus. Positive x times negative x is negative x squared. So sizing it up here, let's see if we can reduce it all. Are any factors identical in the numerator and denominator? I don't see any factors that are identical, but I do see a factor here that is, we have opposite factors. X minus y and y minus x are opposites. Remember, when you cancel or reduce opposite factors, the result is always -1. So I'm going to reduce here by dividing x minus y by y minus x. The result of dividing any factor by its opposite is always -1. So I'm writing that -1 down there to remind me I got to multiply that -1 by the xy for the final result. Our final simplified result then could be written as -xy all over y plus x. And there are several other ways we could express the result here. We could write it as, I just wrote the word or, -xy over x plus y. I just rearranged the order of the two terms in the denominator to put the x first, alphabetical order. Or sometimes people like to put the negative sign out in front of the fraction instead of with the numerator. So we could write it with a negative sign out in front and then xy all over x plus y. All three of these versions here of the answer are equivalent. And there is an example of how you can tackle a complex fraction that involves negative exponents, and that was using method 2.